Hello everyone, this is Chaitanya. My project is face recognition using principal component analysis, and my teammates are K. Tarunteja, P. Devanandraj, and K. Santosh Kumar. We have done this project under the guidance of Professor Y. Vijayalata from the Department of Computer Science and Engineering, Gokaraju Rangaraju Institute of Engineering and Technology. Before discussing about the process of face recognition, let's have a glance about biometrics and its usage in the human world. Biometrics is a science and technology of measuring and analyzing biological data. In information technology, biometrics refers to the technology that measure, analyze human body characteristics such as DNA, fingerprints, iris, voice patterns, facial patterns, and hand measurements for authentication purposes. Authentication by biometric verification is becoming increasingly common in corporate and public security systems, consumer electronics, and point-of-sale applications. In addition to the security, the driving force behind biometric verification has been convenience. A biometric device consists of a reader or a scanning device, software that converts the scanned information into digital format, a database that stores the biometric data for comparison. Need for using biometric identification. Human identification is a very basic societal requirement. By recognizing a face, you could easily detect a stranger or identify a potential breach of security. In today's larger, more complex society, it is not that simple with all growing electronic interactions. So it becomes more important to have an electronic verifications of a person's identity. Until recently, verification was done either based on something the person had in their possession like an ID card or something he knew like a password. The problem is these forms of electronic identification are not very secure. They can be given away, snatched, lost, and can be forged by hackers. So the ultimate form of electronic verification of a person's identity is biometrics. Using a physical attribute of a person is to make a positive identification.
Hi, this is Devanandraj. Why use face recognition instead of other biometric techniques? Traditional biometric techniques include fingerprints, voice, or iris recognition. In many applications like surveillance and monitoring, say of a public face, these biometric techniques will fail because they are time consuming, inefficient, could be costly. We cannot ask everyone to come and put their thumb on a slide or an eye in front of camera or do something similar. So we need a system which is similar to the human eye in some sense to identify a person. To cater this need and using the observations of human psychophysics, face recognition as a field emerged. What is face recognition? Face recognition is the task of identifying an already detected face as known or unknown face, and in more advanced, telling exactly whose face it is. Difference between face recognition and face detection. There is a confusion between these two terms, recognition and detection. Let me clear this. Face detection is to identify an object as a face and locate it in the input image. Face recognition, on the other hand, is to decide if this face is some known or unknown. Basing on the database of the faces it uses to validate this input face. So, face detection's output is, in fact, recognition's input, and recognition's output is the final decision face known or unknown face. How face recognition technology evolves. Automated face recognition is a relatively new concept. Developed in the 1960s, the first semi-automated system for face recognition required the administrator to locate the features on the photographs before it calculated the distance and ratios to a common reference point, which were then compared to reference data. The problem with these early solutions was the manual computations of feature measurements and locations. In 1988, Kirby and Sirovich applied principal component analysis, a standard linear algebra technique, to the face recognition problem. This was considered somewhat of a milestone as it showed that less than 100 values were required to accurately code a suitably aligned and normalized face image. In 1991, Turk and Pentland discovered that while using the eigenfaces techniques, a residual error can be used to detect faces in the images a discovery that enabled reliable real-time automated face recognition system. Although the approach was somewhat constrained by environmental factors, it nonetheless created significant interest in furthering development of automated face recognition techniques. The technology first captured the public's attention from the media reaction to a trial implementation at the January 2001 Super Bowl, which captured surveillance images and compared them to a database of digital mugshots. This demonstration initiated much needed analysis on how to use the technology to support national needs. Different approaches of face recognition. Different approaches have been tried by several groups worldwide to solve this problem, but so far no system or technique exists which has shown satisfactory results in all circumstances. Predominant approaches of face recognition can be divided into two types of algorithms: geometric, which looks at distinguishing features; photometric, which is a statistical approach that distills an image into values and comparing the values with template to eliminate variances. Popular recognition algorithms include principal component analysis based eigenfaces, linear discriminant analysis, elastic bunch graph matching using the Fisher face algorithm, and so on. The existing face recognition algorithms today are not 100% efficient yet. This slide explains the face recognition process. First, we take the input images either through camera or any device. This slide explains the process of face recognition. The first step is we take the images of each individual from webcam, video or scanner as an input. The pre-processing is done by extracting each image features and they are stored in database. The second step is a new image is captured for identification and verification. Using some algorithms, features are extracted and compared those with already extracted features from our database. The result obtained is either known or unknown face.
As I mentioned earlier, here we use the algorithm PCA programming. As I mentioned earlier, here we use the principal component analysis algorithm. Our project explains the concept of principal component analysis. A m by n pixel image of face represented as a vector occupies a single point in m by n dimensional image space. Images of faces being similar in overall configuration will not be randomly distributed in this huge image space. Therefore, they can be described by a low-dimensional subspace. Main idea of PCA for faces: to find vectors the best account for variation of face images in entire image space. These vectors are called eigenvectors. Construct a space and project the images into this face space. These are called.
Hello, I am Taruteja. I am here to explain how the PCA algorithm works. Image representation. Training set of m images of size m by n are represented by vector size m by n. For example, this is 3 by 3 matrix represents a sample image from the training set converted to the single column matrix. The next step is finding the average image and difference images. Average training set is defined by the formula given, and each face differs from the average by vector shown in the figure. Average image is calculated from the column matrix. Average image is calculated by sum of all column matrices by number of input images from the training set. Forwarding different matrix is calculated by subtracting average image from each column matrix. The next step is covariance matrix. The covariance matrix is constructed as C is equals to A into A transpose, where A is the difference matrix. Next step, finding eigenvectors of n by n by n by n matrix is intractable. Hence, we use the matrix A transpose A of size m by m and find eigenvectors of all of the small matrix. Eigenvalues and eigenvectors. If V is a non-zero vector and lambda is a number such that AV is equals to lambda V, then V is said to be an eigenvector of A with eigenvalue of lambda. Example, 2 by 2 matrix with multiplied by 2 by 1 matrix. Hence results 3 into 1 1 matrix. How to calculate eigenvectors by determining of eigenvalues and determination of eigenvector by mathematical approach. The eigenvectors of covariant matrix are V1, V2, V3. Consider the eigenvectors of Vi of A transpose A such that A transpose into A into Vi is equals to Ui of Vi. Pre-multiplying the both sides by A, we have A into A transpose of A Vi is equals to Ui of A Vi. The eigenvectors of covariant matrix are U1, U2, U3. Ui resembles the facial images which look ghostly, hence called eigenfaces. Projection into phase space. How we project our phase space. A phase image can be projected into the phase space by phase image is equals to where eigenphase into difference image.
Now the recognition part comes. The test image is projected into the phase space to obtain a vector as shown. The distance of our obtained vector to each phase class is defined by the given formula. A distance threshold theta c is half the largest distance between any two phase images. This is shown below. These are all done for the image which we have to test. Find the distance between the original image and its reconstructed image from the eigenphase space. With the formula epsilon square equal to mod of tau minus tau f whole square, where tau f equal to u into omega plus sigma. How recognition process takes place as it will check the following conditions. If the distance is greater than threshold distance, then input image is not a phase image. If distance is less than threshold distance and epsilon k is greater than threshold distance for all k, then input image contains an unknown phase. If distance is less than threshold distance and epsilon k equal to min of k less than theta c, then input image contains the phase of individual k. How the computer checks the recognition is following the three conditions. If distance greater than or equal to threshold distance, then input image is not a phase image. If distance less than threshold distance and distance for that image greater than or equal to threshold distance for all k, then input image contains an unknown phase. If distance less than threshold distance and distance for test image equal to min of test image less than threshold distance, then input image contains the phase of individual k. By following the conditions, the computer recognizes the image given. The conditions are: if distance greater than or equal to threshold distance, then input image is not a phase image. If distance less than threshold distance and distance which were formed by following the conditions, the computer recognizes the image given. The conditions are: if epsilon greater than or equal to theta c, then input image is not a phase image. The second condition is if epsilon less than theta c and epsilon k greater than or equal to theta c for all k, then input image contains an unknown phase. The third is if epsilon less than theta c and epsilon of k equal to min of epsilon k less than theta c, then input image contains the phase of individual k. Here epsilon stands for distance, theta c stands for threshold distance, k stands for number of images in the database. Limitations of eigenphases approach. Variations in lighting conditions. Different lighting conditions for enrollment and query. Bright light causing image saturation. Differences in pose, head orientation. 2D feature distances appear to distort. Expression, change in feature location and shape.